right, everybody. Everyone is piling in. Hello, everybody. Still got a minute or two to wait for people to pile in. That chat. Hey, Kenzilium. Wenzel. Got the party here. Got the party. Hey, everybody. So now that we've got quite a few people coming in and got 30 people almost, start chatting you guys up. This is going to be the talk on why Web 3.0 matters. There's a specific distinction about Web 3.0 versus Web 3, and I'll touch on that a little bit, but this is specifically why Web 3 matters, and then because we're all here in this beautiful Motoko Bootcamp and we all love this beautiful internet computer, we're gonna swing this conversation kind of in the direction of why it matters and why the IC can help bring some of it to light. Okay, so first things first, I am Andrew Weed. I have a long career in security, internet security, or information security, and mainly in the offensive world, but I've been in defensive and offensive all around. And I've been in crypto since about 2010, 2011. I've been around. I've watched this thing grow. I've watched both the internet grow and I've watched crypto grow. And it's been really awesome and interesting to see them both grow together, and that's one of the reasons why I wanted to take this talk is to show why Web3 matters and how I see it having grown. So real short answer for anyone who's in the know, anyone who knows what these terms mean and the importance of the terms. The short answer for why Web 3.0 matters is data sovereignty, secure multi-party computing, and decentralized identity. Those are the three big main reasons in my mind moving forward that Web3 really matters and how it's going to improve humanity. So yeah, that's short, and we'll get into the long.
All right. So just before you go on, this lecture is really interactive. So if you have any question at any point, or you want to talk about Web 3.0 and your vision, just raise your hand. All right.
Yes. Absolutely, very, very interactive. Yeah, thanks for saying that, Seb. Yeah, this is not meant to be a teacher-student sort of thing. This is very interactive, and why Web3 matters is going to kind of differ between a bunch of people, and I know that a bunch of people have different perspectives on what some of these definitions are and what they mean. So that's kind of how I wanted to get into the long answer of what Web3 is, and why it matters is just getting into the definitions, right? So what is Web 3.0? What does that mean? So I wanted to kind of go about it in a starting from a historical standpoint moving forward. The web, the term the web was way back in the Web 1 days, right? So the web was coined in the 90s, and that was the whole www, the Netscape Navigator, the early Internet Explorer days. This was where the internet was static sites. It was where the client server model for computing really exploded into popularity. This is when the .com boom happened, right? So the .com boom was kind of the first occurrence of humanity being sideswiped by the power and the capability of technology, right? Of the internet, rather. And so that was kind of, as humanity, that was our first big foray into this giant entity that we didn't really have an idea of what it was. It was this amorphous blob of servers talking to other servers. And so the important part here is focusing on the separation of the interface, the logic, and the data. And so this is why I brought this slide in. I got this slide from a LinkedIn post from someone, and I haven't actually been able to find this Web3 stack anywhere else. And I really, really like this. It's very beautiful. I wanted to talk about the data side. So back in Web1 days, the data was all centralized business data. That was actually the benefit. So before the internet, there was just a bunch of individual machines that were computers, and they did awesome computing work. But if you wanted to get data from one computer or one individual using a computer to another one, it was quite difficult, and you had to offload into some kind of tape or magnetic media of some kind, and it was just not easy. And so the ability for one machine in the entire organization to hold that file that everyone needed, and then anyone could go and grab it from that one location, was revolutionary. And that helped improve humanity leaps and bounds. We couldn't really compare to what we'd done before. The sort of next iteration, I like to call it Web 1.5, is when JavaScript was introduced. So we went from static pages, and we think like Yahoo or GeoCities or things like this. This is way back when the web was just static. JavaScript added some dynamic elements, right? And that was like Web 1.5. And this dynamic elements to the web ended up allowing websites to become applications. And so this is where you kind of see how the logic moves. The internet, you didn't really have connectivity between machines. The web 1 that we just went over, that was where you had websites and static data in centralized sorts of locations. And then JavaScript came out, and we hit Web 1.5, and the dynamic aspect of web pages really started to blossom into something kind of beautiful. And then we figured out an interesting way to make JavaScript make calls out, sort of like we're dealing with right now with the IC, with getting HTTP calls out. JavaScript in browser had an interesting similar sort of parallel. That's when XML HTTP requests, or XHR, and jQuery, and so when these things popped up, and when those things popped up, these JavaScript libraries, and the ability for JavaScript to reach out to the internet from a web application, was really how Web 2 formed. This is when you started getting the concept of like a front end and a back end, where you had a web page that a user would download, and then the web page would then communicate back with the server on its own and have a live relationship, a state. The user's web application in their browser had a state at this point, and so it could change over time. And this was the birth of Web 2, right? And so the technology just built on top of itself, right? And so we had these centralized servers that were managing all of these awesome websites. And so then we had JavaScript that came along and allowed us to start having our users generate data, right? And this was the big switch into Web 2, was when here we want to focus on the data. The data switched into cloud, meaning users generated data, and then that data was stored on the servers of the companies, right? The centralized servers. So when you have billions of people, using these single page applications, right? These applications that download into the browser and then communicate back and forth with the server. Users are generating data, and then the servers are storing that data. Now the massive efficiency gains that Web 1 brought of centralizing all of the data, those efficiency gains are still there, right? There's a massive value of having access to all of that data in one central location. The problem is that we're still stuck in the Web 1.0 mindset of the client server model, wherein the data lies on the server. And so that incredible access to all of that data is had only by the companies, the ones that own those databases. So this is why this particular screenshot speaks so loudly to me, because it does a really good job of delineating the three different aspects of the web that we need to think about. Is not just the interface and how we interact with it, which I'll get into as well. I haven't spoken much about that, but the logic and the data and where they live, right? So the data residency. Data residency is so important now in Web 3.0, and here's why. As we move into the Web 3.0, the data is going to live on the blockchain, and what that really means is data sovereignty. So users can own their data again. The ability for the application to continue operating the way that it did in Web 2. So now we have these incredibly rich applications that are dynamic and responsive, and they have just incredible utility. They are having to be reimagined in the Web 3.0 world, and that is having to be done because of that data residency situation. An application has to fundamentally be aware of where its logic is and where its data is. And current applications, Web 2 applications, are all built with the understanding that the data is owned and resident with the logic on the server, with the centralized server that the company controls. The migration to Web 3 is going to bring along a different mindset as far as how computing works, how the internet works. In Web 1, the internet's in Web 1, the term was the web, right? And then Web 2, everyone kind of saw it as the internet. And so now everyone just says the internet in daily speech, and it is normal. But we're hearing this new thing called the metaverse, and everyone is having a hard time understanding what that is and defining it, and giving this very interesting scenario of like companies renaming to Meta to try and steal definition. Really, what the metaverse is just the next term for the internet. It's taking the internet and including a spatial component, a component that allows humans to interact in a way that is more natural to us in a three-dimensional sort of interactivity. And that's why we bring in interface. So in Web 3.0, the interface is going to be very XR. And that is another, it's another hot topic term. This is full of hot topic terms here. XR really is, it means spatial computing, and that can cover the gamut of anything from immersive 3D and VR, right, all the way into just a cutesy little three-dimensional object floating on a 2D web page on your phone that you don't even notice is really 3D. That's also XR, right? And so the benefit here is that we use the technologies that came before as well as the new technologies, right? So we're not getting rid of the cloud mindset, we're just improving on it, right? And so blockchain is not the end of, like, it's not the answer, right? That's why the internet computer is not a blockchain. The internet computer is is a cloud platform that utilizes blockchain technologies. And that's really what the beauty of Web 3.0 is the fact that blockchain is a tool that can be used to further improve humanity. We don't have to focus on blockchain as the end all be all answer. It's a tool, right? Just like HTTP was a tool, and the
if I can interrupt you, that's
go ahead.
That's exactly like what you're saying right now is exactly why the internet computer really sparked my interest. When I read about it, it's because for the first time, I thought that some people at Definity Foundation had understood like what the blockchain should be used for, but it wasn't like just building a blockchain and saying, okay, we have the best blockchain, you know.
Exactly.
I mean, the blockchain is just a tool for giving trust to people, but you need to use that trust to build something, you know. And that's why
utility.
I think, yeah. So I totally agree with you.
Yeah, I appreciate that. Yeah, and that's really the huge benefit of the IC is that it didn't we're all so early because the IC is not comparable to any of the other like if you can't compare the IC to an L1 or an L2 because it's not comparable. It's like apples and oranges. They're not the same thing. It's difficult because hardly anybody understands what I'm trying to express in this talk effectively. Like Ethereum and ETH are not the same thing, right? ETH is a coin that powers the Ethereum blockchain, and Ethereum is a blockchain. And ICP is a coin that powers the internet computer. NNS, and it powers its own ledger, but it is not. It is a blockchain that runs on the internet computer protocol. It's just like any other ledger. So like XTC and ICP are effectively just two coins running on the internet computer protocol. So it's
just to make it clear. So some people in the chat are saying that they understand, which is cool. For the others, I think you are talking about the difference between ICP the coin and ICP as in internet computer protocol.
Yes, exactly. And there's a bit of a nomenclature issue there because like $ICP is a coin, and that it does have coin-like traits, right? It does act just like ETH does because it's a coin, but ICP, the Internet Computer Protocol, that is defined, that is far and above more than that. The Internet Computer Protocol is much more comparable to what Ethereum 2.0 intends to be in 10 years after it's completed. And the internet computer then starts there and moves forward. It's wildly future tech. And which is, to be honest, one reason why it's kind of like a diamond in the rough. Like no one can understand it, so they can't really, buy into it. But regardless, so what I wanted I'm kind of touching on this Web3 versus Web 3.0 that I wanted to discuss. Web3 is this term that kind of got gobbled up by Ethereum with the Web3.js and whatnot. Web3 kind of means blockchain, right? So Web3 is a very blockchain term. It's very kind of coined at this point. But Web 3.0 would then be the iteration of Web 2.0, which does encompass much, much more than just blockchain. And here's where AI also comes in, is the ability for the data to be separated out of the centralized servers. That's really highly beneficial because what that does is it not only puts the data back in the user's hand, right? So the user not only owns the data, but that means that the data is now available to multiple different organizations that are willing to pay that user for their data. So not only is all of your information that you put on Facebook now available to Facebook, it's also available to anyone you want to make it available to. And let's make it a little bit more serious. Let's not talk about Facebook data. Let's talk about your medical data. So now your medical data isn't stored in one central location at the hospital next to you. Your medical data is actually managed by you in your wallet. Your wallet holds all of your medical data, and you carry it with you. So no matter what hospital you go to, as long as they understand the data schema in which your medical data is written, which this is just a standards problem, right? We just come up with a standard and we go and hit that standard. Now any hospital can read your data, and it's your data. You have it, you own it, and there's no ifs, ands, or buts about that, and there's no way to get around it.
All right. We have a great question, I think. Someone asked, like, everything is nice, but doesn't it mean that everyone will just know your medical data?
No. So if you imagine there's also privacy, end-to-end encryption and privacy capabilities. So the thing about blockchain is that people are used to hearing blockchain, and I think that means that it's like open data, that the data is available. That is not how blockchain is defined. The internet computer does not even provide open data. So the information that is running inside of a canister at runtime is private data. Only the node has access. Currently, only the node has access to that data. And soon, with sandboxing and other features that are coming out, not even the node will have access to that. So the owning that data will be something that has to be unlocked, right? So right now you have, if anyone is familiar with like the Secret Network or Monero or some of these privacy coins, they have private transaction data. So all data on the chain is encrypted, and it must be decrypted with the same private key that you use, just like with your internet identity. It's using your private key to unlock your identity. So it's that it would be under the same sort of schema. You would have access to your data. Your data would be stored on the internet computer in a canister, but that canister is private to you. You are the person that can unlock that canister. No one has access to the data, and until you provide it. And then when you provide access to that data, it's through a canister method, and then a different entity. So like, say if you wanted to connect to your hospital would then have to go to your canister, and you would provide your canister ID, and your canister ID would obviously look like mine would look like Andrew.weed, right? Because of name resolution. So that would not be an issue. So you'd have your canister has a URL, and you can provide that URL to anyone, and that's effectively all of your data. So now you can imagine a social site. So imagine you go to Discover and you post on Discover. What that actually is going to end up looking like on a fully Web3 sort of social network in this fully data sovereign schema that I'm speaking of. What it would end up looking like is the Discover would control the schema by which data is posted and stored through their platform. But when the user created the data, so when I wrote text into the text field and then pressed post, what really ended up happening was Discover would write that data to my identity, to my wallet, and then they would store a record of a link to that in their backend. So then any of my friends would then follow me on Discover, and then they would then have access through the Discover reference link to my Discover data in my wallet. And effectively what you're doing is you're just having the application developer, instead of pointing to the data locally in some database, they point to the data to a reference to your wallet, which is still a database. It's just a much smaller database, and you manage the data, and you manage access and whatnot. So really, it's the same environment that it is now. It's the same apps, the same internet, the same way that everything works, but it's better. And we've disconnected the data from being only capable of being owned and managed and controlled by the database administrator. And we've allowed for humans to control and own the data that that they create in a private and secure way. And that's really one of the big cruxes of Web 3.0, is that users can monetize on their own data. Users can determine who has access to their data. And then the awesome part is that, say I'd used Discover for a few months, and I had a good little catalog of content that I'd created, but I own that content, right? And so now, say another site comes out that's similar to Discover, but maybe it has a better interface or something that I like better, or it's some reason I like it better. But now that site can be what you would call like Discover compatible. So as long as that site is aware of the data schema that Discover uses to store data in their users' wallets, at that point, I would then be able to ingest all of your Discover data, and I can present to you your Discover data in any interface I want. And if you extrapolate that out into what that might mean for humanity, for any of you who were on the social sphere in the MySpace days, MySpace offered this incredible sort of utility for users to modify the CSS of their site. So your MySpace page could kind of look any way you wanted it to look. It was very, very highly customizable, at least for the day. And that sort of environment is really where I think that the future of Web3 is going to be, because when you have a wallet that you control and then all of your data is stored in your wallet, that effectively gives you a personal like blog, if you will. And so all you have to do is slap a front end on that wallet, and you can give anyone your address. And because there's authentication built in, your wallet will know when you're logging into it and can give you the interface to manage. And your wallet will know when someone else is logging into it and can give them the interface that you want them to have, some kind of front end to you. So yeah, that's how users are going to really be empowered by Web 3.0, by having access to manage their own data, and where their data resides is really the power. And then the benefit to that, even being more abstract and meta, is that it's going to protect the fundamental human right to private identity. So right now, your identity is highly tied to your geographical location. And by that, I mean, when you're born, you are born in a hospital that probably takes some kind of record of your birth and then sends it to the government that hospital answers to. And then you get an ID card 18 years later or so, that states that government is aware of who you are, and that if anyone else wants to validate who you are, they can go talk to that government and ask them and validate. Well, we're no longer reliant on that government. The government is obviously still going to be there, and then governments are great for humanity, but the fact that a government is the custodian of your identity is a little silly to me. I think that human identity is a right that each human has, and I think that you should be able to take your identity with you to a different government and not have to worry about a government holding your identity or something interesting like that. So yeah, this also offers the ability to have humans maintain their own private identity.
All right. I'll try to basically sum up what you've said in the latest 10 minutes, I would say. So I will
Yep.
try, because we discussed a lot of concept here.
Yes.
So your vision of Web 3.0 is, instead of having websites that like own the data, we would have protocols that would allow people to basically use their data and share their data when they want, and
Exactly.
through a wallet. So they would like hold the data in their wallet, and they would give the access to this data or this NFT or this whatever is inside the wallet through a signature. And basically you're saying that this way of designing the internet would be a protection against like any form of tyranny or any form of malicious government. That's what you're saying.
It would be a protection against any sort of attack that may fall under like that kind of category, like a Byzantine attack or something. Someone taking power over you due to your identity. They could not do that, which is what the government currently does, right? So the governments they maintain their power over people using imprisonment, right? So taking away your freedom of movement, and then they also prevent you from living somewhere, right? So if I wanted to go to a different country, I would have to make sure that it was okay with not only the country I'm coming from, but going to. That will not change, but the country that you're coming from will not be able to control the information about you. They will not be able to control your identity. They will not be able to. That's not their data effectively. So that centralization of data. If you think of any, across all of humanity, if you think of any current central data repository, anything like that can and will be decentralized. So such as Social Security Administration databases, right? So these things will eventually be decentralized. I like to think of it like currently the social media is defined as like websites or applications, or even now we're moving into like the cloud platform as descriptive words, right? Platform would be a descriptive word for like what a social network could be right now. But when Web3 really blossoms, I think that the social network is going to be defined by a protocol. So if I own my data in my wallet and you own your data in your wallet, there's just like back in elementary school when you would make notes to your friends and make little languages that only the two of you understood, and then write notes back and forth to each other in that language. You could effectively build a social network in a similar way. So I have my wallet, you have your wallet, and we define our own special little data schema by which I can write things to you in your wallet and you can write things to me in my wallet. And that data schema is now a social network that others can follow. And it's that as long as that protocol is published, effectively anyone can use it. And then the composability of the internet computer, and then Web 3.0 mainly, right? The asynchronous nature, but the composability allows for a really drastic re-implementation of this front end back end concept. It's, I think, is now moving into more of like a wallet / contract concept. So really it's going to be a wallet interacts with another, really a contract interacts with another contract, because a wallet is a smart contract, but at least on the internet computer, it's a canister. But the fact that Entrepot does not have a competitor right now is surprising to me, because the way that the internet computer works and the way that Web3 works is that currently it's simply just a front end to all those canisters. the like the whitelist. People talk about the whitelist of NFTs on Entropod. Like if you were to just build a front end for all of like all of those same canisters, you could just do the same thing. You could just it's you don't need to use the front ends that the developers provide for you anymore, really. And the massive benefit here on both sides of the coin is that not only is this open availability that I'm speaking of possible, but we can also do it the other way still also, right? And so like Discover can continue operating the way it is. It doesn't have to start writing data to users' wallets. It can continue maintaining a backend with data. And if you want to be a Discover user and go look at a Discover user's content, you go to Discover, right? And that's the way that we're used to it. If you want to look at someone's Facebook page, you go to Facebook. But it doesn't have to be that way. So I can now determine that instead of going to look at Seb's Facebook, I'm now going to just go to Seb's page, and Seb's page is going to have his Facebook content, but it's also going to have his Twitter. It's also going to have his Discover. It's also going to have all of his other content because it's his content, and he can choose how to display it, where to display it, and if to display it or not. And that's really the massive power of Web 3.0 and why it matters. And then the last point that I kind of wanted to make and wanted to touch on for sure is the secure multi-party computation capabilities. So this secure multi-party computation is incredibly advanced stuff. So it's not something I'm going to get into too much. But what it is it allows for you to take data that needs to be processed. So any kind of information. So if I'm taking your social security number and I'm processing it for a credit card, right? I need to process that social security number. That's private data, and some computer somewhere needs to process that private data. Well, if one computer processes that data, then that one computer has the ability of knowing what that data is in its entirety. But if you were to able to cut up that social security number into multiple different pieces and then process it across multiple different machines, and no one machine had all of the information, that would be a much more secure way to process that social security number, especially if you could guarantee mathematically that when you put the information in and when you got the information out, it was mathematically accurate to as if you had done it with one machine versus multiple. With that capability, we really have an interesting future where data privacy is complete, in that data can be both encrypted at rest, encrypted in motion, and encrypted as it's being processed. In compute is what the industry would say. So I think that with the ability to do processing on that was the other part that I didn't mention. Not just the multi-party computation, but the secure multi-party computation. So not only are you spreading the workload out across multiple machines, but you're also doing it on encrypted data. And this is the crux of the cryptography of SMPC, is that it uses what's called functional encryption. And so the functions and the methods that you guys are going to be writing during this course in Motoko and in Rust, they take in data that you could understand. They take in string data. The user submits their name, and that name gets sent back to the system, and you could print out that name. With a secure multi-party computation, or with functional encryption at least, the function that you're submitting that data to wouldn't actually operate on raw data like that. It would only operate on encrypted data. So with that function, the machine doing the computation does not know what it is computing on. It's just computing on encrypted data.
All right. So
Yeah.
what you're saying is that so right now, for example, my canister is let's say composed of multiple nodes. I think it's 7 in the lowest subnets. And so the problem with that is that 7 machines are basically doing the same calculation and storing the same data. So it's a bit wasteful. So you're saying that there is a fix to that?
I mean, there is a fix to that. That's a little bit separate of what I was talking about. So that is in the consensus. That's speaking about the consensus. So that the reason that there's 7 machines that are doing one thing at one time in each subnet in the internet computer is for consensus. So that if any one of those machines was malicious, the other ones could determine that and still provide you the correct answer as opposed to whatever the malicious answer was going to be. So that's actually a benefit of the system. And then the balance of finding the right number of nodes to be not wasteful, but also provide good consensus and security for the data that you're computing. That's kind of a balance that we're going to have to find as humans moving forward. But I was talking more in the ability to process workloads. So if you needed to process some machine learning data, which is potentially highly private data, and this is the sort of workloads that isn't necessarily friendly to this discussion or the people in this discussion as an entry level or an intermediate level dev bootcamp. But when you're talking about massive machine learning workloads and data sets that are really staggering, but then also incredibly private in the medical field and whatnot, these data sets, you don't want anyone to have access to the data inside the data set, not even the people doing the computing. And so what I'm referring to is maintaining the privacy of that data set, even when the machine that is computing on that data set may be malicious. It has no access to the data. It is entirely encrypted. And then the multi-party computation, the benefit isn't really in so much that you're taking the data and breaking it and so it obfuscates. That is a part of the benefit, but really the benefit of multi-party computation is that you can take a single workload, I need to do this one thing to all of this data. And instead of only having one machine do that one thing, you can split that one thing across many machines, effectively horizontally scaling that task at will. And then the beauty about secure multi-party computation, like I was saying, is the fact that no matter how wide you spread that scale horizontally, every one of those machines is computing on encrypted data. So it doesn't even matter what the data is in the first place. And that is very those sorts of those three things: the users having access to maintain their own data, and their own identity, maintain private identity, and then also the secure multi-party computation. I think those three things combined allow for a very matrix-looking future. The internet computer could become a very interesting beast if all humans were capable of managing and maintaining all of their data in a private way, and then trading and sharing that data at will.
Do you think the internet computer is the singularity?
I don't necessarily. I try not to marry myself. I'm allergic to dogma, so I try not to marry myself to any idea. Like you could probably convince me that 2 + 2 wasn't 4. I've been convinced of it mathematically before. Not convinced, but there's a nice little trick where 2 + 2 is 5 or something like that. But no, I wouldn't say that I think it's the singularity so much that I think that the growth of technology is not linear, and that's pretty obvious. And so because it's not linear, at some point, no matter what kind of horizon or scale you're looking at, it's going to become asymptotic, right? It's not linear. It's going to go one way real fast at some point. And I think that is entirely related to scale. So what is your scale that you're looking at? And if we take the scale that I've taken here and we look at the internet as it first started, and kind of look at computing at the very beginning of computing in the 70s and 80s, and then if we look at the scale from there all the way till now, then yeah, I would say that the internet computer could be seen as what would be defined as like the singularity. But I could also argue that maybe Ethereum would be as well, only because it provided the opportunity to do compute that no one can stop. That is a singularity causing event, not utility and adoption. Really is where people think of singularity, right? Because then it's like, oh, well, it's ubiquitous. Well, everyone knows about it, and so it's kind of like you can't get away from it, and it's this all-encompassing thing that everyone is. That's what I think about when I think of singularity, and so I think that Ethereum probably provided that feature set, but I don't think Ethereum is going to be that thing that eventually everyone's just going to kind of have in their back pocket, and everyone's going to know the name of. But I hope it's the internet computer. I think that the internet computer is the first platform that has the long. I think the internet computer is the first platform that has long enough teeth to do it. I hope that it is the one that does it, but adoption is really what's going to tell in total honesty, because there could be a competitor because the internet computer has done it and it's open source and they've said how they've done it. It's entirely plausible that Amazon could throw, $100 billion at redoing the internet computer. Like Jeff Bezos could literally get watch the wrong DOM video and get a wild hair, and now instead of a space company, he's got a blockchain company, and the internet computer just gets trounced. It's possible. So
Yeah.
I wouldn't necessarily say it's gonna be this one. I really do hope it is, but we definitely have the possibility.
I think on that, if I were Jeff Bezos, I think it would be smarter to just try to put the money into the current ICP without trying to like create another one, because in the end, it wouldn't really change the I mean, trying to restart from zero with the community that is already existing,
Mm-hmm. Yeah, and that's I mean, like it's adoption, really. It's the community that's going to drive it. But I think that honestly, Motoko Bootcamp here is a great example of how we're going to push that forward, right? We're gonna get more developers in here realizing the power of what we can do, and it's going to take it's a learning curve, right? Because of that, the data residency capabilities that the blockchain is offered and that the internet computer provides. It's going to be a big paradigm shift in the way apps work. So yeah, it's going to take a lot, and we're leaning on a lot of you guys, you developers that are going to be going through this bootcamp right now. We're leaning on a lot of you guys to help build some of this stuff that I'm talking about. Some of these future dApps that bring utility to users directly instead of to the developer of the dApp, right? So that's really, I mean, if you think about the network effects of these sorts of things, that's really how we're also going to defeat big tech, right? So big tech currently exists because a couple of nerdy dudes who know how to write websites write a good website and then store all of the data that everyone in the billions of people that use that website create. It's just a couple of dudes, and so those couple of dudes don't deserve all that power and all that money, right? And the people that created, they deserve a lot. I'll say that if you create a good app and it's successful and you had a good idea, then you deserve to be a millionaire. You deserve to have a Lambo. But I mean, Jeff Bezos doesn't need to be worth what he's worth, because Amazon is not worth what it is. Like, Amazon is not worth the price that it's worth. It's the users of Amazon are worth that price, and the users of Amazon should go back and get that value but Amazon's currently getting that value. So yeah, that's it. We're going to need everyone here to reinvent social economics.
Right. That was really interesting. Super presentation. Do you have something else, or we can move to the question because we have a lot of questions.
Yeah, no, we have a lot of questions. Yeah, that's fine. No, we can roll with questions now. I'll hit it.
Yeah. Okay. So I've skipped a lot of them because it wasn't like in the flow of what you were saying.
Yeah, for sure.
So the first question was really at the beginning. It was, do you think that Internet of Things is also part of Web 3.0?
Yes. I think that Web 3.0, like kind of like I said, Web 3.0 and the metaverse are very similar. So any device that connects to the internet, like as you see it now, if the device connects to the internet, so IoT, right, then yes, it's part of Web 3. So really, I mean, I think that people are trying to overly define this why Web 3.0 matters. It's almost kind of oxymoronic because we're trying to get overly definitive about what Web 3.0 is, what metaverse is, what internet is. It's just the internet. Like, and even that, the internet is not even complex. Like people don't even understand what the internet. It's really just your computer speaking to someone else's computer. That's what the internet is. That's all it is. That's all it's ever been. That's all it's ever going to be. But the complexity of that other computer that you're speaking to is really what we're talking about. And right now, the complexity of that other computer is not very high because it only allows you to store, it will only store the information you give it, and then it doesn't let you do anything with that information, right? It's all centralized. The computer that you're going to be talking to in Web3 is actually doesn't care about your data. It cares about the operation and what you're doing with that data. So you are going to post data to a social platform for all of your friends to follow. And that's the goal of what you're doing. And so what's going to occur is you're going to post the data and then everyone is going to just have access to that data. And it's not, the system is going to allow for everyone to have access to that data without the system needing to like own it or be maintained or managed or it's the beauty of smart contracts and there's like deterministic computing really is that you just you don't have to trust that third party. It's a wonderful thing to have a computing platform that allows you to do logistics with data, to send data between two disparate locations without that third party having to be trusted, or rather it is trusted inherently through math. So that is another pet peeve that I kind of wanted to get out here and tell people. It's not trustless, right? So this world that we're moving into is not trustless. The fact is that you are just no longer trusting a human, you're trusting mathematics, because you still have to trust that the internet computer is not malicious, right? But if you can look at the code, which you can, and you can review it and then identify that really all you're relying on is that no one can break the mathematics, then your trust is in that no one can break the mathematics.
Yeah, I have something to say about that.
Yeah, go ahead.
I think personally that there are really few people in the world right now. Maybe I don't think someone like alone can like certify the internet computer, like, you know, saying, okay, I've looked to everything and I know that it's 100% safe. So I think what is really funny is that we are trusting humanity in a sense, you know, to get right about the internet computer and the fact that it's not malicious. So, you know, yes. I'm trusting like people with more experience. I'm saying, okay, like if they look at the code and they don't see any mistake, then it means that it must be working, you know, but I'm not like personally 100% sure.
Yeah, and the cool part about, well, the interesting part about security is neither of that, right? So any security assessment is only a security, it's a point in time assessment. And what that means is that you're assessing the security from the perspective of one individual, which may not be that no individual is perfect, right? And so someone is going to be able to find something that someone else can't, didn't rather. But there's no such thing as a perfectly secure system, because tomorrow someone may have found a vulnerability to that system that you didn't find, and now it's a 0 day, and now there is a vulnerability to the system, right? And so there's the only secure system is the one that's turned off. That is entirely true. But you can mitigate. The thing about risk is that you can mitigate risk to the point where it becomes unfeasible for an attacker to actually perform an attack. That's the goal, right? So you just make it as difficult for an attacker to perform the attack as possible. That's why we rely a lot on math, because we have restricted computing. Our machines can only do certain types of math so well. And so we trust that no one in the world has a machine strong enough to break this math. That's literally how our crypto works. And which is why quantum computing is so scary, because quantum computers do math differently. Quantum computers do math kind of more like humans, where if you talk to like a math professor or someone who's really good at math and you ask them a math question, it's as if the answer just popped into their head. There's no possible way they could have computed it, seemingly, but they did. Full disclaimer, I'm fully of the belief that humans are, the human brain is a quantum computer of some kind. So take that into context here. But the idea of a quantum computer breaking the mathematics of our current crypto systems is viable and feasible, and is a worry, which is why we're working on quantum secure cryptography, right? And so that's something I'm also talking to a lot of people in the DFINITY ecosystem about. So the quantum readiness is also something that Web 3.0 is going to require.
All right. So someone was raising the hand. So let's. All right, Dan, you can ask your question. You might need to. Yes. Okay.
Yeah. Hi. Yes, I just wanted to, having lived through the entire spectrum of what you had displayed on your slide, I have to applaud that you've really captured a good progression of the whole thing from my perspective. The one thing that I might suggest is that your little red box around blockchain for the Web3 world, or the DFINITY environment, really should include the AI, because the AI apps or programmed code is running inside of this secure layer. And but I think it's really fine what you said. I think we talk to us as technocrats, and we are all technocrats in building this stuff, but I think we're also opening up the nature of the internet toward social engineering, because we now have this trust layer that can help us establish computing environments that don't have to worry so much, that now we can apply and have the social engineering knowledge that we need in order to build these. And there's a whole design revolution that has to come with that. So we're going to engage people more than us technocrats in designing those solutions. That's all I wanted to say.
Yes, exactly. I appreciate the content. Yeah, so on the comment about AI being integrated in blockchain, you're correct. The point really in separating them is what aspect of the system is performing that role in the interface or the logic or the data. So the AI is using the data to perform logic, and so yes, the AI is running on chain for sure, and that is something that will also definitely be the internet computer provides the capability of. But really, when you're talking about like the data on the AI part, it's the model, right? So like the model is stored on chain, and so that data is going to be on the blockchain, and then also the compute the compute layer also runs on the block. The backend compute can also run on the blockchain. But that's also something that I wanted to point out that I wanted to highlight. The introduction of Web 3.0 does not mean that Web 2.0 or all the technologies that live in Web 2.0 are going away. They're just being supplemented. So we're still going to have centralized providers of things. We have sexes and we have dexes, right? They're both available. So it's not like it's going to be like a hard shift. It's just going to be a spectrum. And I think that that's really beautiful, honestly. The spectrum currently exists in some way or another. Like you could effectively use the internet entirely through Tor. And if you use the internet entirely through Tor, you're going to have a very different experience than someone who doesn't do that. And you'll have different privacy affordances. So it'll be just like the internet computer. You can use certain, you'll be able to use Facebook, and whenever they come out with their Web3 social aspects, you can use some of the decentralized stuff or use the centralized Facebook Web3 social media, whatever it's going to be.
All right. So we had a question on I think back then on zero knowledge proof on the IC. Do you have something to tell about that?
I mean, just that's pretty. I mean, it's like two broad topics: IC and zero knowledge proofs. So zero knowledge proofs are, when I'm talking about secure multi-party computing, those are a part of secure multi-party computing. A zero knowledge proof is a piece of information that can be provided to someone to validate that a computation was done without the information that was computed being revealed. So effectively, it's similar to you coming and asking me, are you 18 years of age? And I can hand you my ID that says yes, but you can't see anything on my ID except yes. But you still believe it, and it's mathematically proven. So zero knowledge proofs are what is going to be used in part to achieve secure multi-party computing. I don't know if that answers the question, just in general about zero knowledge proofs and the IC, but yeah, that's a sub technology for secure multi-party computing.
Yeah, okay. So I think the question was like how the internet computer manage such concepts.
That is an incredibly complex answer. I would have to do a little bit of research to give the answer accurately. And there's others that are much better at that than me. But if you do want that answer, there's really, really good videos on Dfinity's website about the internet computer internals and like how consensus works, how the message protocols and message routing works, how like every aspect. It's very, 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 very awesome content.
All right. Okay, so do we have any other question? I cannot. Yeah, maybe I've missed some of them. So if your question was skipped, please say it again.
So I see that there's some discussion about trust and whatnot, and I'm not following completely, but I know that I mentioned how you're not going to have to trust a third party. The thing is that the human interaction started at the very, very most abstract level between two people trying to trade some kind of information, right? Whatever that information is, it's just me trying to get you some information and then potentially you remunerate me for that information in any kind of way, right? Let's trade. So really the trading of information between two parties securely is what we're trying to achieve. But we need to do it digitally, right? Electronically over the internet. So you are going to have to trust the party you are trading with, right? So if you're on like as a really basic example, if you're on the playground and as a kid and you walk up to some kid and you're like, hey, I like your rock, here, have my leaf, and you trade and you hand him the leaf and the kid runs off. Well, like, yeah, you still got to trust the dude that you're doing business with, but the benefit there is that you then add this third party, right, where you're like, hey, we've got this disinterested third party where you can hand them the rock and I can hand them the leaf, and then they can hand us each the other item so that we know that we're not gonna like get screwed. So that is the next answer that humans like came up with, right? So we did that in digital form, which is centralized servers, right? So now, oh, go ahead.
Yeah. If I try to sum up what you're saying again, you're saying that like the trust in mathematics is related to the trust in the world, like the metaverse that we are gonna maybe experiment and trade on, but not to like the specific interactions. So it's like
Correct.
in the real world, you know that people cannot cheat because there are laws, there are the nature, like the physics, like people cannot just teleport into your house and steal your goods. And on the IC,
there's
it would
laws
be
of physics.
exactly, and on the IC, it would be like the laws of mathematics, I guess.
Yes, exactly. So because everything is a smart contract, right? Then it's all deterministic, which means if I'm going to run, if I'm going to submit some input to this contract, I know that this particular output is going to come out. And that is trust, right? And I can mathematically prove, I can read the code, and I know it's going to run that. And then I know that the machine running it, the node running it, right? There's 7 of them. And so if one of them is malicious, or at least 7 of them, and so if one of them is malicious, I know that the data is still going to be computed correctly. If there's, so you just kind of build the risk boundaries, the trust boundaries around your entire process and your entire system. So really, you just want to make sure that there is no way to attack any part of the system. And so that third party that you need to trust to trade the rock and the leaf, if that person is a centralized server, if you're in a digital world now, then you need some way to allow that centralized server to not be trusted, because to be trustworthy without having to trust a human, because humans are inherently not trustworthy. Not that because we have choice, right? That's effectively what we're talking about here. Computers don't have choice. They run what they are told to run, and that's it. So if you can rely on a computer to do that, and then mathematically assure yourself with cryptography that the computer is doing what it says it's doing, and it's not doing something that someone in the background is telling it to do without your knowledge, then you can effectively have that third party where you don't have to trust the person that you're doing business with, and you don't have to trust the third party, as long as you can trust yourself in validating the contract that you're interacting with. So yes, in practice, you will not have to trust anybody, as long as you can validate all of it yourself, which is really hard. But as long as it's available, technically, then it can be automated. So then this trust can be automated, right? And it's going to take a lot of work. It's going to take rewriting the internet and the way dapps function, right? And this is why Dom talks about that. He talks about how the internet is going to have to be reimagined. It's because the internet currently is imagined in a way with central databases, and that's going to have to change. Like literally, databases will not need to exist. Your data doesn't have to live next to everyone else's somewhere in a central location.
All right. So I think we have a very interesting question. We have also the chat saying that this presentation is turning into a philosophy class.
Yeah, true. It's very, very high level, like what Web 3.0 means and how it matters. That's kind of why I said I liked it to be interactive, because it's very, very abstract, high level concept stuff. And so this is you can definitely get lost in how high level it can get. But
that's why it's so interesting, I think.
exactly, I agree. It opens up the possibility for a utopia, which is in and of itself wonderful. It's just, it's now on us as humans and practitioners of this technology to build that utopia, right? So that's kind of why I wanted to take this course, is because if I want a utopia to exist, then who am I if I'm not putting that out into the universe? That's what I'm doing here.
Yeah, I agree. We have a question like on the current level of decentralization of the internet computer. Like, let me find the question. Where is it? Okay, so what do you think about how much decentralization the internet computer is now, and how is going to change later?
What do I think about the decentralization of it now and how it's going to change?
Yeah, because right now I
Yeah.
think we are not reaching perfection, I
Well,
guess.
Well, yeah, I mean, decentralization is also it's one of those things that you got to define in an interesting way, because it is decentralized in some ways and it's not decentralized in other ways. So like the computation, that's all decentralized because there's no single computer that does any computation on the internet computer. All the subnets are spread out across at least 7 nodes. And so every canister that you run is decentralized. But at the same time, is there an availability for like a Byzantine actor in that right now? I think if you were to get real deep into a conspiracy level, you could probably find a Byzantine actor that could achieve something on the internet computer right now, but I think that would be really hard. And it would be an effort that, it would be very, very difficult for someone to do that. But I think that most people are really worried about the decentralization of the coin, really, ICP. And that is very, very up for debate, right? So there's massive amounts of locked neurons that are like seed neurons that are dispersing. And so there's these seed investors that have tons and tons and tons of ICP that could very likely have the ability to drive the market. But at the same time, there's this interesting sort of paradigm where if you're a seed investor and you believed in it back then, and you look at it now, and you have a half of a head on your shoulders, you wouldn't sell. So it's super interesting to talk about decentralization of the coin, because it's very debatable, right? I don't have the answer as far as what it really is or isn't, because I'm not a seed investor, and I definitely don't have that kind of cheese. So I'm not sure if I would say that the entire ICP coin itself is decentralized well enough yet. I do, however, think that the NNS, I think that the NNS is decentralized enough. So the DAO that runs the ICP effectively, I think it's decentralized enough right now. And I say that because the only actor that I'm aware of right now that could actually make some kind of malicious action would be like Dfinity and Internet Computer Association combined. Like the 27 and 28 neurons, if they both voted to do something, it would happen. but simultaneously, on the flip side of that, you have to understand the trust that would break, right? So if that were to occur, it would be an immediate and critical cripple to the internet computer. It would immediately just shut everything down, effectively, in my mind, because the trust would be completely gone, right? So that would effectively be an attack by themselves. And yeah, so I just see Kyle Langham. I highly recommend go check out Kyle Langham's posts on all of his analysis. It's incredible.
Yeah,
he has a Substack. But yeah, so as far as the NNS being decentralized, I think that it is decentralized enough right now for us to act as a community as though it is, and to submit proposals and look at the system as if it is operating in an optimally decentralized way. Because I think that the only actors that could disprove that are also stand the most benefit to actually achieve decentralization.
Yeah,
so
that's also what I believe. And sorry to interrupt and just like
no, go ahead.
throw my personal opinion on that. I also think that the rules of I think the main problem of the supply is also that the governance. So the governance is like the double-edged sword, because it's so powerful to actually, solve the issues that arise in for example, the Bitcoin community with the block debates, the Ethereum community with the hack of the DAO debate, and even just improving the chain. But at the same time, it's also like I understand that it's more complexity, so probably it can, I don't know, afraid some people or whatever. But I think what is cool is that the rules of the NNS can change, and also what is cool is that we have the SNS and all other like governance. So my hope is that like first the NNS rules will maybe evolve in the future. If for the moment it's not really important, because as you said, the decisions that are taken are really quite basic, I would say, and for the moment the IC is so small that there is no actual benefit to like try to screw the NNS for the people that would try to do it. And yeah, I hope that in the future maybe the rules will evolve, and as well that we will move to different model of governance, because there will be the NNS, but there will be also like each application will have its own rules, and each community will decide what is best for like the community. And yeah, but there is a lot to say about governance for sure.
Yeah, exactly. Yeah. Yeah, and the governance thing, and with the NNS and governing the internet computer, it's interesting because the internet computer is not, it's a platform, it's not a blockchain, so it's not comparable to Ethereum. So all of these users that you're talking about, like Ethereum users, right? So if you want to get an NFT on Ethereum, you have to understand how Ethereum works to some degree. You have to know MetaMask, you have to get the private key, seed phrase, these things you have to be somewhat aware of. But because the internet computer is like a cloud platform, it's not actually made for the end user, it's made for the developer, which means it's in the Web 3.0 world, right? In this future metaverse that we're kind of talking about, the internet computer is actually going to be the platform for entrepreneurs. The person who wants to build something that brings value to humanity, that thing's going to run on the internet computer. And so end users are actually not going to necessarily be aware of the internet computer. Just like if you want to use Hulu, you don't have to know about AWS. You are using AWS, but you don't have to know about it at all. Similar here. So I think that the biggest benefit to the internet computer is going to be when an application that runs on the internet computer is bigger than the internet computer as far as community or popularity is concerned.
Yeah.
Because that's really how it's like, effectively, I can promise you that the word Netflix is more popular than the word AWS, right?
Yeah.
But Netflix uses AWS. So every single time someone uses Netflix, Amazon makes money, right? So that's how the internet computer is that I see, right? So like, I can be a Discover user and have no idea that the internet computer even exists.
That's difficult right now, I think.
It is difficult right now, but
Yeah. But I totally
we're
get
getting there.
what you mean. Yeah. And
Yeah.
I hope the entrepreneur that is going to create this super mega application is on the bootcamp right now.
Exactly. Yeah. And I'm very I'm hoping the exact same.
Yeah. All right. So we are 20 minutes after the time that was planned originally.
Yeah.
If someone has another question, it's the time now. All right. Yeah, I think we can end here. That was a really great presentation.
Thank you. I appreciate it. Thank you, everyone in the chat, for all the great questions. I appreciate everyone's time and listening to me wax on. I appreciate it. And hopefully I'll see you guys in the metaverse.
Yeah, see you.